Big round of applause.
네, 반갑습니다. 방금
Good afternoon. I'm Yeon Jeong-hum, and I'm the head of the R&D department of BPA. Today, I'm going to talk about smart and 5G-based Busan Port digital twin platform. And this is a table of contents, current situation, concept of digital twin platform of Busan, followed by future goals and plans. First, current status. Well, Mr. Jin-gyo already had a presentation this morning, so let me be brief. Well, we were placed on the 3rd place, and as of 2021, we're the 7th largest container terminal, and in terms of transshipment, we're the 2nd largest. And the throughput is 22 million a year, and we believe that the figure is going to increase to 32 million TEU by 2030. And in accordance with increasing throughput, we are developing the Busan ports, and we're going to build port infrastructure which will enable 54 very large container ships by 2030 at the same time. And next is about how we are operating the port. So from manned, it moved to mechanization to unmanned automation. So between equipments and between people, we sometimes fail to communicate, and that led to safety accidents. So the picture that you see is that there is a vessel 3 years ago that was entering the port speeding, and there was a crash as a result. And in the middle, in the vessels or with trucks, you can see that these vehicles collided. And on the far right, the average area of the terminal is 800,000 square meters. It's a very large area, and it's very difficult to monitor this large area in real time. The second challenge is that it's very difficult to optimize the operations of the terminal. Of course, we have the pre-work plan using the terminal operation system, or TOS. But on site, we have many variables, and we failed to stick to the original plans, and also there can be changes of information, and there can be late arrivals of trucks and vehicles, and also there can be accidents. And in this case, all these variables lead to unexpected outcomes. The last challenge is in the gate area and in the hinterland area, there is heavy traffic congestion. The productivity of a port is about how many containers are handled by cranes. But in reality, it's really about how vehicles and vessels arrive on time, and then they have to leave on time so that it doesn't lead to any bottleneck. And we were not always efficient when it comes to this bottleneck or dealing with these issues. And due to the corona pandemic, the volume of container cargoes increased drastically. So this has become an important issue. In order to resolve this, we need to share information and have effective communication. So regarding the lack of information and differences of schedule, we thought that developing digital twin platform can be effective. What that means is that we can build the exact same environment in a virtual environment, and using this digital twin, we can do the data linkage, modeling, and search past data. And using fine-tuned simulations, we can make better predictions, accurate predictions, and make forecasts for the future as well. And also, it enables unmanned autonomous operations. I mentioned various challenges in the port of Busan, and we thought that digital twin can be the best solution to solve all these issues. In overseas markets, there are various attempts using digital twin technologies. For instance, in the port of Rotterdam, it announced a plan for 2019 digital twin technology and installing IoT sensors and securing safety of workers and vessel traffic management. It is closely working with IBM. And also, in the port of Singapore, it is keen on developing the smart shipping, and it's currently building the Tuas port. And in Germany, in the port of Hamburg, it's trying hard to resolve the traffic congestion using smart road systems. And using the IoT sensors, the sensors can identify where the bottlenecks are created, and it can change traffic signals based on the outcomes. And the last one is the case of a Finnish port, Oulu. So it's about dealing with the safety of entry and departure of vessels. And cranes, vehicles, these are being monitored using the digital twin. So they were the 4 examples of overseas ports. And next I'm going to talk about how these digital platforms can be used to connect the hinterland logistics functions. And even though we haven't developed this concept in a full manner, I believe that for a particular or specific terminal, we were the first case to develop such a digital twin platform. We carried out a demonstration project, and that was for this particular terminal, Busan New International Terminal, PNIT. This was organized by the BPA, and that was about increasing the productivity, linkage of the hinterland, and improving integrated platforms. And that was supported by the Ministry of Science and the Busan Metropolitan City using public and private funds. And also, it got support from the Ministry of Fisheries in an administrative efforts. And this is about data linkage and optimization of scheduling between three different elements: ships, ports, and hinterlands. And regarding ports and vehicles and the GIS data, operation schedules are integrated to come up with optimal navigation data and optimal navigation route. And receiving the real-time TOS information, control can be given, and also simulation modeling and virtual terminal can be realized. And this is how the Busan Port Digital Twin Platform hardware looks like. So from the digital twin server, you can see all the necessary information that's presented and analyzed in real time. And also this one shows how the hardware looks. In line with the government communication policies, it's based on 5G, and it can receive data for location in high precision and high speed. And the digital twin server is located in the server room of the PNIT, and the data is being utilized by the control center. And this is the actual image, as you can see from the left bottom end. This shows the actual entry and exits of the Busan port in real time, and the red line shows the optimal entry route, and the yellow shows the exit route. And on the top left, it is the navigation route, and this information is given to shipping companies and vessels. And the second image shows the general statistical information that is shown on the integrated dashboard. So if you do the comparison of the effects of the digital twin platform, predictability used to be 75%, and that increased to 92%. Data consistency increased to 95%. And by resolving traffic congestion, fuel consumption improved by 30%. This data utilized and reflected the full-scale ship data that was built by DSME and operated by HMM. And on the second slide, this is about the productivity increase. And on the top right, you can see the location information and toss information that is shown in real time. And you can do the monitoring of this data. I told you that the area is about 250,000 pyong. So it's rather big to do the monitoring accurately. And if you put the cursor on the part that you want to see, then you can check the information that you'd like to see. And also the yard container information is also presented. And by clicking on this image, you can tell which shipping company, who's the owner, and what cargoes are being moved. And on the bottom, this is the virtual terminal that was realized. And the loading and unloading outcomes can be tracked back using simulations, and also we can optimize the activity. And also you can adjust the volume of cargoes. And also the schedule can be adjusted depending on whether the vehicles or vessels arrive on time or are delayed. And with the introduction of the digital twin platform, this is the effect that we analyzed. So when it comes to the throughput, it was very difficult to predict the throughput, but now we can do it with the digital twin platform. And the optimization based on schedule led to productivity increase of 16.7%. And in the yard tractor, in the past, it was not GIS based, but currently now we can use the GIS information and it's optimized to increase productivity by 15.4%. Next is about accuracy, how we increased accuracy and how it is connected to hinterland logistics. So the turnaround time and entry departure time, these are analyzed and monitored. And that led to the improvement of traffic congestions by 10%. And gate in and gate out time is reflected in turnaround time. If the turnaround time is very long, then that means more traffic and more congestion. So by reducing the turnaround time, you can actually reduce the load of the port. Next. Last is the integrated data platform. Virtualization is a good tool, but on the other hand, what we want to do is to do the integral analysis of data, and that's what we're providing exactly. Regarding vessels and cargo trucks, there is less time for them to wait, which leads to less CO2 and better air quality. Currently, this is not being deployed because we need at least 7 to 10 years data, but currently we only have the data for the past 5 years. So by accumulating more data, we believe that we can advance this function. Next one, future goal and plans. By 2027, we have this plan to have the digital twin platform to cover the Busan Port as a whole, and that will lead to the reduction of 11 million ton CO2 reduction. And the operational cost will be reduced as well by 12 billion won. So our plan is to advance the platform operation plans, and starting from 2024, for the next 3 years, we will complete the digital twin platform development project. So you can refer to the rest of the slides for more information. And also we're working on the algorithms, and you can refer to the remainder of the information. So with that, I'd like to conclude my presentation on the digital twin platform. The Busan Port, the Port of Busan, will lead, and to become the leading port in the world, we'll do our best.